Vanakkam. Myself, Kadirvel, Assistant Professor at Aeronautical Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to discuss about engineering thermodynamics. So, first of all, we should know what is called thermodynamics. The thermodynamics is a word that is derived from a Greek word. Therm means that is heat energy, and dynamics means power. And thermodynamics can be defined as the study of relationship between the work and heat energy. And it's a science which deals about the energies possessed by the gases and the vapors. And that it also gives the interaction of a system and its surroundings. The flow of energy is the greatest importance to the engineers involved in the design of equipments in the power generation and process industries. The heat can be converted into work and work can be converted as heat. So both are mutually convertible. So today the conversion of heat energy into power plays an important role in power generation, jet propulsion systems, turbines, compressors, heat pumps and refrigeration systems. And it also plays a major role in biomedical and chemical industries. In this connection, we are going to talk about the first law of thermodynamics and its applications and approaches of thermodynamics, thermodynamic systems and its equilibrium conditions, processes and heat and work. Thermodynamics is the branch of science that deals with the energy transfer and its effect on the state or condition of the systems. So it's basically entails four laws known as zeroth law, first law, second law, and third law of thermodynamics. So zeroth law is talk about the equilibrium of the system. The first law is talk about energies of the system, and second law talk about the efficiency of the systems, and third law is defines about entropy of the systems. So there are four laws: zeroth law, first law, second law, and third law. So based on these laws, these thermodynamic relations will apply to the engineering applications like automobile engines, turbines, compressors, propulsion systems, and aircraft and rockets, combustion systems, HVAC systems, cooling of electronic equipments, etc. etc. These are the some applications of thermodynamic studies: thermal power stations, engines, hydropower stations, refrigeration system, biomedical applications, and turbojet engines. Thermodynamics is a field of science which deals about the energy possessed by the substances and in the interaction of the system with the surroundings. With this way, we are having two types of thermodynamic approaches with the systems. One is a macroscopic and a microscopic approach. So it is well known that every substance is composed of a large number of molecules. The properties of the substances depends on the behavior of these molecules. The behavior of the system may be investigated from either a microscopic or macroscopic point of view. These approaches are discussed below as a competitive way, in a comparative way. So as far as microscopic approach concerned, the matter is considered to be comprised of a large number of tiny particles that is known as molecules which moves randomly in a chaotic fashions. The effect of molecular motion is considered. And the large number of variables are required to describe the systems in the microscopic approach. This approach is used to study of the statistical thermodynamics and the properties are defined each molecule individually. As far as the macroscopic approach, certain quantity of matter is considered without taking into account the events occurring at the molecular level. So analysis concerned with the overall behavior of the systems, and the properties like pressure, temperature, etc. needed to be described the system can be easily measured, and few properties are required to describe the systems. This approach is used to study of the classical thermodynamics. Microscopic approach is used to study the statistical thermodynamics, and here it is for classical thermodynamics. Next, different types of thermodynamic systems. So thermodynamic systems, there are three types. One is open system, another one is closed system, another one is isolated system. Before that, we should know what is a system. It is defined as a quantity of matter or a region or a space upon which the attention is concentrated for investigating the thermodynamics properties or the thermodynamic analysis. That properties may be heat transfer, work transfer, that pressure change, temperature change, etc. etc. So wherever the region you are selected, whatever the matters you are considered for thermodynamic application analysis, that is called a defined area is called, or defined volume is called thermodynamic systems. And the thermodynamic systems which is separated from the surroundings by the boundary line. The matters which are all outside the system is called the surroundings, and the surrounding and system is separated by a line that is called the boundary. This boundary may be a fixed or moving boundary, real or imaginary boundary. Okay. For example, you can take any classrooms, or you can take any engines. We are considering only about the process happening inside this engine. That combustion chamber is called a system. Outside of this combustion chamber is everything outside is called surroundings, and the engine body is called the boundary. Okay. So with this, we can define the system. The system is a quantity of matter or a specified region where this thermodynamic analysis will be done. Okay. So the first system is open system. It's very simple. In a system, the quantity of mass along with the energy will cross across the boundaries. Then the system is called as open system. Okay. The space where you are considered, there is an mass flow and energy flow takes place, means that the system is called open system. If only the energy transfer takes place and there is no mass transfer, means then the system is called a closed system. And the third system and the isolated system has no mass transfer and there is no energy transfer. So this is an imaginary system. It's perfectly isolated. It is an imaginary systems. For example, thermo flasks. Okay. So these are the different types of thermodynamic systems. So thermodynamics is a branch of science which deals about the energy possessed by the substances and gases, and it gives the interaction of the system and its surroundings, and it works based on the four laws, that is first law of thermodynamics, second law, third law. These laws are called as 4 E's. That means the zeroth law is also called as equilibrium law. First law is called as energy law. The second law is called as efficiency law. Third law is called as entropy law. So based on these laws, this thermodynamic analysis are done on the different systems. So these analyses are classified into two approaches. One is a microscopic and macroscopic approach, and the system analysis having an systems, different thermodynamic systems. First one open system, second one closed system, third one isolated system. Okay, with this we are stopping here, and we will discuss about processes, properties, etc. in the next video. Okay, thank you.